So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle, it's way thicker. And this is the core. Wait, what's happening here? Uh-oh, the core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's Central Anatolian Plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time, and as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow! It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called Cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American Craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient Cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that Cratons might not be as indestructible as they thought. Some Cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like Cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has three main parts: the Western Block, the Eastern Block, and the Trans-North China Orogen, a zone that lies between the two blocks. Scientists found that during the Mesozoic era, the Eastern Block lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They have found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure, and that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists looked closely at their chemical makeup, they realized the age of crystals matched the rocks found in Greenland, not Scandinavia. They used special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other.
The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, Shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, There was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Tell me the truth. You probably think that Earth's magnetic field is caused by a big ball of solid iron in the middle of the planet, right? Yep, I mean the inner core. But the problem here is that in the inner core, the temperatures are so high that the very magnetism of iron itself is changed. Once such a temperature, which is called the Curie point, is reached, atoms aren't able to align to a magnetic point anymore. So, in reality, Earth's magnetic field is created by the swirling outer core, and magnetism there is more than 50 times greater than it is on the surface. The liquid iron in the outer core conducts electricity perfectly, which helps it create electrical currents driving the magnetic field. Without it, our planet wouldn't be able to hold onto its atmosphere. As a result, we'd lose our main protection from extremely dangerous space radiation. But it wasn't the outer core that surprised us not so long ago. Scientists say Earth's inner core has likely stopped rotating relative to the mantle and the surface of the planet. Even more exciting, it could even go into reverse. But let's look into the details. Earth is formed of the crust, mantle, and outer and inner cores. The solid inner core is about 3,200 miles below the crust. It's separated from the semi-solid mantle by the liquid outer core. Yep, the one thanks to which we have the magnetic field. And since this outer core is liquid, it allows the inner core to rotate at a speed different from the speed of our planet's rotation. Earth's core has a radius of 2,200 miles and is almost as large as Mars. It mostly consists of iron and nickel and makes up around 1/3 of Earth's mass. The spin of the inner core is powered by the outer core. It turns out that the slowing of the core started in 2009. Since that time, seismic records, which had previously been changing continuously, have shown little difference. And it makes scientists conclude that the inner core's rotation has paused. But we're nowhere near the scenario of a disaster movie. Apparently, the inner core taking a temporary break is part of its 70-year-long cycle. During this cycle, the core switches directions every 35 years or so. This might influence Earth's magnetic field and the length of the day, but some researchers are skeptical about it. And some scientists even go as far to say that the inner core isn't moving at all. Okay, but what would happen if Earth's core indeed stopped rotating? Well, if it was the solid inner core, the answer would be nothing dramatic. Even if it didn't just reverse the direction of its movement, like it's doing at the moment, but stopped altogether, it would just impact the speed of Earth's rotation. It'd slow down, making our days longer. Plus, with time, it could probably degrade our planet's magnetic field, and it would be bad news. But not as bad as they would be if the outer core stopped spinning. As you already know, without this layer's rotation, Earth would have to kiss its magnetic field goodbye, and that's how the downfall of the planet would begin. Things would start getting shaky. The tectonic plates would begin to slam into each other. You know, like when you're going by bus and the driver suddenly hits the brakes and you end up flying into other unfortunate passengers? Yeah, like that. The sudden collision of tectonic plates would trigger destructive earthquakes along the plate boundaries all over the world. They would wipe buildings, bridges, and roads off the face of the Earth. Water systems, electricity, and phone lines would also be destroyed. But the worst would be yet to come. Without the protective magnetic field, cosmic radiation would start hitting the surface of our planet. These high-energy particles coming from the sun would come in contact with oxygen and nitrogen in our atmosphere, effectively destroying our ozone layer. This would allow even more cosmic rays to reach the surface of Earth. The radiation would damage all kinds of electronic devices and disable power grids. And the consequences would be disastrous, not only for people, but for all forms of life on Earth. The stationary core would make navigating the planet more difficult. People would have to start using trail maps again, since compasses would become useless. It would also make it harder, if not impossible, for migratory animals to find their way. Birds would keep losing directions, and turtles would fail to find beaches where they used to lay eggs. Luckily, we don't need to worry about this kind of apocalyptic scenario. The planet's outer core is very unlikely to stop anytime soon, if ever. Now, do you want to find out something cool? Then listen to this. Our planet's inner core has a core of its own. Scientists have made this discovery just recently. They've learned that this core in the core could have developed around 500 million years ago as a result of some dramatic geological changes. What about other planets? Do they have the same cores as Earth? Let's look at Mars, one of our planet's closest neighbors. Its heart is the size of the Moon. It's also almost twice as dense. Scientists made this conclusion after they got some data about the first observed Marsquake and meteorite impact. Both these events were captured by NASA's InSight lander, which had been monitoring seismic activity on the red planet for 4 years. The researchers also estimated that Mars's core is probably made mostly of a liquid iron alloy with a smattering of hydrogen, oxygen, and carbon. One day, Mars probably had a nice rotating core that supported the planet's magnetic field. There could be warm oceans swarming with life. But then, something must have happened, and on one terrible day, the red planet's core froze in place. It could have led to the weakening of Mars's once strong magnetic field. Its atmosphere was taken away by powerful solar winds, hitting the planet at a speed of several hundred miles per hour. And the red planet turned into a lifeless, dry desert. Now, what about gas giants? Let's take the largest and the most massive planet in the solar system, Jupiter. It's twice as massive as all other planets of the solar system combined. Almost 1,300 Earths could fit into this huge thing. Jupiter also has the shortest day in the solar system. It lasts a mere 10 Earth hours. At the same time, the gas giant needs 12 Earth years to complete an orbit around the Sun. Jupiter most likely appeared at the same time when the rest of our solar system formed, about 4.5 billion years ago. Probably the coolest thing about this gas giant is that it has the same ingredients as a star. But unfortunately, or should I say luckily, it hasn't grown massive enough to ignite. Scientists don't know for sure what Jupiter's core looks like. According to most theories, the gas giant has a dense core made up of heavy elements. During its formation, it was probably a collection of debris, icy material, and other small objects like comets and asteroids zipping around. Thanks to their mutual gravity, these bits of matter clumped together, forming larger chunks which later turned into Jupiter's core. At one point, it became massive enough to start attracting hydrogen and helium. More and more gases accumulated around the core until what we today know as Jupiter appeared. There's also a possibility that Jupiter doesn't have a core at all, or it might have existed once, but since then, it's eroded away. Hopefully, we'll find out the answers to these questions soon enough, since Juno, NASA's space probe, is orbiting Jupiter, collecting data about its gravitational and magnetic fields. So, what about the gas giant's magnetic field, you may ask? Does it even exist? Oh, don't worry. Jupiter is surrounded by a ginormous magnetic field called the magnetosphere.
Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the Sun. We think of the Sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the Sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the Sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about negative 140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The Sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another: the inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it, and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangaea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking, and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the ring of fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. Every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear, which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing.
Imagine a world of seething hot metal where iron and nickel dance in a fiery inferno. This is the inner core, the heart of our planet. But what if this very heart was changing? The latest research suggests that the Earth's inner core may be slowing down and even reversing its rotation. Is this a sign of the end of times? Will the Earth come crashing down on itself? Let's find out. Imagine you have a giant onion, and every layer represents a different layer of the Earth. The center of this onion, the part you can never reach, represents Earth's core. It's like a mysterious land that no one has ever set foot on, yet scientists have been trying to uncover its secrets for centuries. Imagine diving deep into the center of the Earth, beyond the crust, the mantle, and finally 1,800 miles below the surface where you'd reach the inner core. It's a ball of seething hot metal made up of solid iron and nickel, and it's so hot it glows a brilliant white. It's also surrounded by a liquid outer core. This mysterious place is unlike anything else on our planet. And get this, it's spinning on its own axis. The inner core is like a fire tornado that's constantly swirling, generating heat and energy from the inside out. But why is it so important to study this little piece of the Earth? Well, it's responsible for creating our magnetic field. This magnetic field is important to study because it protects us from harmful radiation from the sun. It's created by the movement of molten metal in the Earth's outer core and the spinning of the Earth. These movements generate electrical currents, which then create the magnetic field. It's like a shield that protects us and helps us keep our planet healthy and safe. But there's still so much we don't know about the inner core. For example, how did it form? Scientists believe it started to solidify about 1 billion years ago. But why did this happen? What was the trigger? Or, for example, what about the inner core's crystal structure? It's thought to be a type of iron called hexagonal close-packed iron, but we still don't know if it's actually the case. In other words, we may have many theories, but unfortunately, there's no way to confirm them, at least for now. So how do scientists study the inner core if no one can go there? They use seismology. Seismology is like a sonic scanner for the Earth. You send sound waves through the Earth and measure how they bounce back to see what's inside. That's basically how we discovered the inner core way back in the 1930s. Imagine you're listening to the sound waves with your special seismology machine. Suddenly, you hear a strange sound like a ping. It's different from the other sounds you've been hearing, and you can't explain why. You keep listening and you hear the ping again and again. You start to realize that this ping is happening every time the sound wave hits the Earth's center. You study the data more and more, and finally, you figure it out. The Earth has a solid core. This discovery was a big breakthrough and helped us better understand what's inside our planet and how it works. Right now, scientists also use something like this to study what's inside our planet. When earthquakes occur, waves travel through the Earth and bounce off different layers, including the inner core. By studying these waves, scientists can learn about the inner core's properties, such as its density and temperature. They're basically solving a mystery by piecing together tiny clues. And every new discovery brings us one step closer to understanding it. The inner core is a unique and fascinating part of our planet. It's a place where the laws of physics work in different ways than they do on the surface. And it's a place where scientists are still trying to unravel its many mysteries. And here's one of them. For some reason, the heart of our planet is about to stop spinning. A new study about this was published in Nature Geoscience. It was made by the researchers at Peking University in China. It has revealed a huge twist. The scientists found that the inner core spin rate has slowed down significantly. It's something that no one expected, but according to the results of their study, the slowing down began all the way back in 2009. And that's not all. Their results also suggest that the inner core may be reversing its rotation. That's right. This hot ball of iron and nickel that has been spinning around for millions of years may be slowing down and changing direction. It's like when a spinning top starts to slow down, except this is happening in the center of our planet. Scientists have been puzzled over the discovery for quite some time now. So, what does it all mean? And why is this happening? Well, it turns out that there might be a larger pattern at play. The scientists believe that this change in the inner core's rotation may be due to the influence of Earth's mantle and the magnetic field of Earth's outer core. The mantle and the outer core are affecting the inner core, which is causing its spinning rate to slow down and potentially change direction. Before this study, scientists thought that the inner core was spinning faster than the Earth's crust. However, this new information suggests that the inner core may be slowing down due to the gravitational effect of the Earth's mantle and the magnetic field of its outer core. But here's where it gets even more interesting. When researchers took a closer look at data stretching all the way back to the 1960s, they discovered that the rotation of Earth's inner core was consistent from the late 1970s to the early 2000s. Before that, they found that another possible slowing down or reversal event may have occurred in the early 1970s. It's like the inner core spin is like a roller coaster ride, speeding up, slowing down, and possibly reversing course over a period of time. The researchers estimate that these switches occur every 7 decades or so, which is pretty wild. But why is it happening? Unfortunately, we still have no idea. The exact reasons for why the Earth's inner core sometimes stops and starts spinning in another direction aren't yet well understood. However, Scientists believe that it may be due to complex interactions between the solid inner core and the surrounding molten outer core. A lot of different things can be at play here. The changes in the temperature, pressure, and composition of the core, as well as the movement of material within the core itself, and so on. Also, as we said before, the Earth's magnetic field and the gravitational forces from the surrounding mantle might also play a role here. We need further research to fully understand the mechanisms behind the inner core's rotation changes. So, is the world ending? Fortunately, no, not just yet. While the inner core is changing direction right now, it's not the end of the world as we know it. And even though findings may seem like a huge deal, life on Earth's surface hasn't been impacted much, if at all. In fact, it's just a fascinating part of the Earth's inner workings that we're learning more about every day. So, you can say with relief, nothing cataclysmic is happening. Moreover, according to Hrvoje Kalsic, a geophysicist at Australian National University, the inner core is now more in sync with the rest of the planet than a decade ago when it was spinning a bit faster. All in all, this new study has added a strange twist to the story of Earth's inner core, and scientists believe that there's still much more to discover about this mysterious place. Who knows what other secrets lie in the heart of our planet? The possibilities are endless. So let's keep researching and enjoy our time on this amazing planet. You're a seismologist working at a geological observatory. In the morning, you check the equipment that monitors seismic activity and adjust the instruments. Then you inspect the movements of tectonic plates. Suddenly, one of the devices shows a strange signal. It's like a small earthquake. You make a record of this push and continue working, but the signal repeats again. A little time passes and the devices fix it for the third time. You understand that this is not an earthquake because the signal is too weak for this. It repeats every 26 seconds and resembles a pulse. The human heart pulses close to the center of the chest. The pulse of the planet also comes from its center, the equator. You call other specialists and tell them about the unusual phenomenon, but no one knows what it is. Also, you can't determine the source of the pulse. You arrive at the place where the vibration comes from and find nothing. The ground still pulses under your feet, but it's impossible to figure out the reason. In the 1960s, the pulse called Microseism was discovered by seismologists in the US. More than 50 years have passed, but scientists around the world still don't know the nature of this phenomenon. It looks as if our planet has a heart hidden inside its crust, beating every 26 seconds. According to researchers, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea. This area is called the Bight of Bonny. Every winter, the pulse becomes stronger. Then it weakens again by the summer. When scientists began exploring this place, they put forward a theory that the ocean could create the pulse. Waves hit the continental shelf of the planet. That impact deforms the ocean floor. A human hand hitting a table works on the same principle. Sit on one side of the table and put your hands on it. Let someone else hit the table from the opposite side. You will feel a vibration. Ocean waves hitting the coastline create a similar effect. Someone may object that there are waves all over the world, not only at the equator. Yes, but that's where the sun heats our planet the most. Solar energy causes powerful storms and winds and accelerates ocean currents and waves. Also, in 1980, geologists found out that Earth's tremors became stronger during storms. In other words, when waves hit the shore with more power. Not all scientists agreed with this theory. Some researchers believed the planet was pulsating because of the seismic activity. It was coming from a volcano located on one of the islands in the Bight of Bonny. The place where the pulse was the strongest is close to the volcano. But further observations showed that the Earth's tremors happened in all parts of the Gulf of Guinea. That's why scientists can't prove any of these theories. Our planet pulsates not only from within. Earth is surrounded by a thin luminous halo. It's constantly changing its shape and shimmering with different colors. If you look at our planet using special equipment, you'll see that Earth is inside an uneven pulsating bubble. It's located at an altitude of 50 to 400 miles above Earth's surface. This bubble is called the ionosphere. That's a layer of charged particles that separates the upper atmosphere from space. In other words, this is the boundary that sets apart the region where you can still breathe and a complete vacuum of space. The International Space Station travels inside the ionosphere. Most of our satellites also move within the borders of the pulsating bubble. This natural phenomenon can both help and disrupt the operations of communication and navigation systems. It helps radio and GPS signals to get to our mobile phones, but it can also interrupt the stable connection. It all depends on the number and density of charged particles. Sunlight takes away 1 or 2 electrons from the gases surrounding our planet, and they become charged particles. These particles make up the ionosphere. It's constantly changing its shape and size. It happens because the planet rotates around its axis, and the sunlight falls on it unevenly. During the day, the ionosphere is always larger than at night. Because of this pattern, it's pulsating and constantly moving. This instability shortens the life of orbiting satellites and often puts them out of work. Radio and GPS signals pass through the ionosphere and get reflected from charged particles. Then, they fly further to their destination, to phones, navigators, and other devices with GPS and radio receivers. Our planet is not only pulsating, but also buzzing. The noise that Earth produces is called the hum. It's impossible to record this sound, but even so, 2 to 4% of people on the planet hear it. All over the world, people who aren't connected in any way speak about a weird buzzing sound. It interrupts their sleep and doesn't let them concentrate. This noise follows them everywhere. Perhaps you also hear it but don't pay attention. But once you notice the hum, you won't be able to unhear it. Some residents of a small village in Scotland describe this humming as a thick, low-frequency sound. There's a website on the internet with a map where people all over the world register and describe this mysterious noise. Almost everywhere, it's a low-frequency vibration, barely perceptible to the human ear. Sometimes, people say it resembles the noise of an airplane flying overhead, but quieter. Some people describe it as the sound of a running truck engine placed in the backyard. It's humming in the street when they come home. And it gets louder when they are lying in bed. If you hear it too, you can mark it on the map. There are records dating back to the 19th century that describe a sound similar to the hum. But for the first time, the media started talking about this phenomenon in the 1970s in England. Since then, many theories have been made by scientists and people who try to catch the hum. There is a hypothesis that claims the noise comes from high-speed traffic on highways, or it might be caused by too many airplanes flying in the sky. The hum and vibrations can be produced by electric stations, factories, industrial equipment, and huge air vents. Some people believe the reason for the hum is the movements of tectonic plates and the Earth's crust under the ocean waters. But no one has managed to prove it yet. In most cases, people hear the hum in big cities, and, of course, they often complain about this and demand to conduct investigations. But all the attempts to find the source of this noise haven't given any results. It's possible that 4% of people have a unique hearing that catches low-frequency sound waves. One theory says the source of the hum is special radio signals. They're used around the world to communicate with submarines. These radio signals can make people have a response. It feels as if you hear some buzzing. This happens when radiant energy collides with the soft tissues of the human skull. It stimulates the auditory nerve and creates an auditory hallucination. But the coolest theory appeared in the city of Sausalito in California. A lot of people there hear the hum, and biologists believe that fish might be the reason. There are many toadfish on the west coast. They can produce a unique sound that is not audible itself, but the sound wave coming from the fish resonates with the buildings located near the coast. This resonance produces the hum. Even one fish can do this. Imagine what happens when thousands of these sea creatures scream at the same time. But not only people living near the shore have problems with the noise. Those who live in the city center hear the hum too. And since the sound waves created by the fish can't spread so far, the theory was quickly refuted. Our planet isn't the only humming one. In 2020, scientists recorded a strange buzzing sound on Mars. This is a quiet, long beeping that spreads across the red planet's surface. Sometimes it changes a bit because of Marsquakes, which are another mystery. Earthquakes occur on our planet because of the tectonic plates' movements. Stress accumulates and gets released in the crust. This produces earthquakes. But there's no plate tectonics on Mars, so Marsquakes aren't supposed to be happening there.
In the world's deepest gold mines, people work at a depth of over 13,000 feet. The deepest oil well on the planet is the Z44 Chavo oil and gas well. Located in the Russian Far East, it goes more than 40,000 feet down. That's 15 Burj Khalifa towers put on top of each other. One of the world's deepest and most famous artificial holes is the Kola Super Deep Borehole. Its depth is also over 40,000 feet. If you dropped a coin down the shaft, it would be falling for 50 seconds before it reached the bottom. A mere 9 inches across, this well was created for scientific purposes. People wanted to drill through the Earth's crust and see what lay below. They managed to pass only 1/3 of the way. After that, the temperature reached 356 degrees Fahrenheit, and the drill couldn't operate any longer. But what if, by some miracle, you managed to drill a hole all the way through Earth? You've got through 8,000 miles of molten magma and solid rock. You've withstood the temperatures of almost 11,000 degrees Fahrenheit and extreme pressure, more than 300 million times more than at the surface of the planet. The well is wide enough for an adult to pass without having to squeeze through. It's also perfectly straight. The hole's walls are incredibly strong and won't collapse or melt. And then, while standing on the well's edge, admiring your handiwork, you slip and fall into the gaping abyss. Considering gravity, acceleration, and the Earth's diameter, it would take you just 42 minutes to fall through the entire planet. You'd reach the maximum speed of 18,000 miles per hour at the Earth's center. And in less than an hour, you'd emerge on the other side of the planet. Unfortunately, in the real world, you might not even get through the first mile of your fall. The Coriolis effect is to blame. Our planet's surface moves at a speed of 1,000 miles per hour at the equator, but Earth's insides don't need to move that fast. Picture a racetrack. Traveling along its inner part, you'll drive a shorter distance than when moving along the outer side. It means that soon after falling into the hole, your speed will become greater than that of the hole around you. After traveling for 1 mile, you'll crash into the side of the well and begin to careen and bounce off its sides. If you were halfway to the center of the Earth at that point, your speed would be 1,500 miles per hour faster than the walls of the hole. But let's say you know about this effect and manage to avoid it by digging a hole directly through the Earth's poles. Only in this case will the gravity pull you straight down. On your way to the Earth's center, you'll see tons of cool stuff. First, you funnel past countless rabbit warrens and mole tunnels. By the way, a mole can dig a 60-foot long tunnel in a day. When you're about 10 feet down, you have a near crash with a giant earthworm. If the creature was standing, it would reach your waist. At a depth of 26 feet, you dash past the tunnels dug under the Mole Man's home. William Little, a British civil engineer, spent about 40 years to create an enormous web of caverns and burrows stretching far beyond his house. Almost twice deeper, and you're speeding by a Nile crocodile. This reptile digs the deepest burrows among all animals. You hardly have enough time to recover from this shock when you fly by is it an underground farm? Indeed, you spot vegetables and herbs growing there. You zip through the bottom of the deepest swimming pool in the world. It's the Y40 diving pool in Montegrotto Terme, Italy. It goes 131 feet down. For some reason, it's not filled with water at the moment, and you need a mere 3 seconds to reach its bottom. When you're more than 500 feet underground, you spot people lounging in a hotel room. It's Sala Silver Mine, the world's deepest hotel, built in a converted silver mine. At a depth of 3,300 feet, you start to experience immense pressure. It feels as if 4 elephants were piled up on your head. After that, you can continue your journey only if you're wearing a suit that can protect you from the ever-increasing heat and air pressure. You move deeper and see the Homestake gold mine, almost 5,000 feet below the surface. Before closing, it was the deepest and largest gold mine in North America. In the 1960s, scientists detected and counted tiny subatomic particles from the sun. They did it in a lab located inside the mine. After falling for another second or so, you reach permafrost. It's a thick, permanently frozen layer of soil that doesn't warm up even in the summer. It mainly occurs in polar regions and is the thickest in northern Siberia. Now you're more than 6,000 feet below the surface, and you still come across some living creatures. Those are springtails, teeny eyeless insects that live in the Krubera Cave in Georgia. But the deepest multicellular animal you meet lives at a depth of 11,800 feet in the Tautona mine in South Africa. Tiny, but incredibly hardy, this worm can deal with extreme temperatures and dehydration. 4 miles down, and you dash through the oceanic crust. It's the part of the Earth's crust that lies under the ocean and is much thinner than the continental crust. Twice deeper than that, and the tunnel leads you through a pool of scorching hot molten rock. That's Yellowstone supervolcano's magma chamber, below Yellowstone National Park. It means you're about to leave Earth's outermost layer, the crust, behind. The deeper you go, the hotter it gets. At the boundary with the mantle, about 18 miles below the surface, the temperature reaches 750 degrees Fahrenheit. Now you're moving through Earth's upper mantle. The pressure there reaches 10,000 atmospheres, like more than 130 elephants standing on your head. But it's nothing compared with the lower mantle pressure, 240,000 atmospheres. The temperatures keep rising as well. Near the boundary with the planet's core, it's already more than 7,000 degrees Fahrenheit. The outer core is 1,500 miles thick and is made mostly of iron and nickel in their liquid form. There, Earth's magnetic field is 50 times more powerful than at the surface. You are more than 3,000 miles down underground when you reach Earth's inner core. It's incredibly dense and spins faster than the rest of the planet. It's almost as hot as the surface of the sun, 9,800 degrees Fahrenheit. The pressure inside the inner core is 3 million times greater than on the surface. And still, you somehow make it through this solid ball of metal and back to the surface. In real life, though, you'd be crushed by immense pressure and burned by incredible temperatures soon after the beginning of your fall. No suit would be able to protect you from such extreme conditions. Even if neither pressure nor scorching heat influenced you, you'd still have several serious problems on your hands, and all of them would be connected with air. For one thing, it would be air resistance. It would pull you to a stop long before you reach the core. But a much worse issue would be air pressure. The deeper you'd get down the hole, the more air would be above your head, and the higher its pressure would be. At a depth of 30 miles, it would be as great as that at the ocean bottom. After several hundred miles, the air would turn into an almost solid plug blocking your way. But let's say you knew about this problem in advance and pulled all the air out of the well before plunging in. And now, you're moving in a vacuum, dressed in a special suit with a large oxygen supply. Still, you're going to come across something bizarre on your way. During your fall, you'll notice that the force pulling you downward starts to weaken, and once you reach the center of the planet, it'll disappear whatsoever. Earth is an almost perfect sphere. That's why the gravitational forces coming from the mass surrounding the planet's center counteract one another. Feeling equal pulls from all sides, you'll become weightless. Paradoxically, you'll be floating in the air and moving at breakneck speed at the same time. Soon, you'll travel through Earth's inner core and keep going until you get to the other side. In any case, this situation is entirely hypothetical. The very idea of building an 8,000-mile-long tunnel sounds implausible. You'd need to find where to store all the material pulled out of the hole, including Earth's molten insides. You'd also have to ensure your tunnel wouldn't collapse while going through the planet's liquid layers. its walls would have to be made of a material that could withstand the heat of more than 10,000 degrees Fahrenheit. So far, no substance on Earth can remain intact at such temperatures. It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali plate just wants more space, so it's pulling away from the Nubian plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.